So just a quick introduction to what Catalyst does. Catalyst, we clean up and republish um, publicly available US energy data so that other people, such as you, don't have to. And we've been working with a bunch of these data sets for, 8 years, some for less. And we're just excited to share a moderate amount of the learnings we've gleaned over the last several years with you all today. So yeah, let's get to it. Here's an agenda with some timings. I'm not going to read everything out loud, but basically, we're going to start by talking about sort of the types of data publishers that are out there. Um, and then we'll do a quick little exercise to reinforce some of that learning before talking about um, actual individual data sets. We're going to go into breakout groups and investigate the data sets um, with specific questions, specific, you know, actual piece of data. And then we'll come back, talk about it, sort of see what we've learned. Then we'll talk about data republishers, so people like us who take the data, clean it up, and make it easier to use. Um, and we'll have an exercise about that as well, and come back and discuss. Very simple strategy of talk about something, try using it, talk about it again. And then hopefully there's a very short and easy closing section. So that's that. As you can see, if you've been following along the notes, by the end of the workshop, you all are going to be able to explain the trade-offs between a couple of different types of major energy data publishers, identify sort of what is actually in some of these data sets, and then also make your own decisions on when you want to use data from republishers versus using the original source. There's also a code of conduct. Please follow it. There's a link to it so you can go and read it, but also the very short version is don't harass anyone for any reason. And if you're being made to feel uncomfortable, please DM me, Christina, or Austin, and we will try to mediate that as best we can. And then one final logistical thing before we jump into the presentations. This is a living document, so we're going to be editing it over the course of the workshop. So follow along on your own. Once we start getting into the exercises and content, I'll also be sharing my screen. There is a questions section at the very bottom. Put questions in there, and then we'll try to answer those in line as the workshop goes on. We'll also expect you to write down the answers to the breakout group questions inside the stock so that everyone can see them. To make everything a little easier, everything that has a blue header is somewhere where we expect to be typing stuff, just to orient you in the document. And please don't unfold or fold any sections yourself because that makes the document skip around for everybody. Yeah, that is basically it. We'll send out notes afterwards as long as you give us your email. And yeah, whoever has the whole thing highlighted, that does make everyone see your highlight. So that would be nice to unhighlight, but it's not a huge deal. Okay. Zane, do you want to start talking about the data sources?
There are literally hundreds of different publicly available data sources in the US that relate to the energy system and the energy transition. And there's no way that we could possibly, enumerate them all in a workshop format like this. But we'll share some background with you in the materials afterwards. What we really want to try and do today is dig into patterns that we've seen across many different data sources that we've worked with in the energy space and some of the trade-offs that you may end up needing to make when you're choosing what data to work with in a research or policymaking context. So there's a bunch of different kinds of sources and publishers of data in the US. There's the federal agencies from really all across the government. Almost every government agency has some information that it publishes that is relevant to the energy system. There are these regional utility organizations that have overlapping jurisdictions and are often involved in planning or operating the energy system. There are, of course, the state regulators, almost every state has a utility commission or a Department of Environmental Quality that collects and publishes information about the energy system. There's national labs like Lawrence Berkeley and NREL, the National Renewable Energy Lab. They do a ton of modeling and analysis and publish a bunch of reports, often with supporting data alongside them. And then there are open source and open data projects like ours, PUDL, which is the Public Utility Data Liberation Project. And a lot of the open data projects are more kind of bringing together data from various sources and trying to make it more integrated and easy to use. Although there are some like the OpenStreetMap that are really collecting data and publishing it for the first time in any form. There are a bunch of NGOs that work on policy that publish their own reports and often have supporting data, although those will of course be focused on whatever the use case or policy case that they're trying to make. And then a lot of academics will publish data alongside their peer-reviewed work. Hopefully in a usable form, though not always. And it's really useful to understand the different kind of motivations and incentives that lie behind these organizations. So who are the target audiences that they have in mind, and what are they collecting the data for? What do they think people are going to be using it for? Some organizations really put data at the core of their mission and identity. They'll often have researchers and policymakers and rigorous analysis in mind with the data that they're publishing. So, on the social sciences side, the Census Bureau publishes, a vast amount of information that is used by researchers all over the country. And then NOAA and NASA have a ton of remote sensing and weather data. And these agencies, they have a research use case in mind. The national labs are a different kind of organization. So they have a ton of technical capacity and are very rigorous. They value scientific rigor. But unlike the federal agencies, they're almost quasi-private organizations, and they have more of a competitive project-based funding model. So once a report or a project is done, they may or may not ever come back to it and update the outputs. On the other hand, there are federal agencies like FERC, the Federal Energy Regulatory Commission, which is not really primarily involved in or does not primarily think of itself as a data provider, but it does happen to collect a lot of data as a byproduct of its regulatory role. And there's a lot of uniquely valuable information in there about, like the accounting for utilities. Unfortunately, because it doesn't think of itself as a data or statistical agency, that information can be really, really hard to work with. So just one more concrete example, NREL, a few years ago, they did this big study of kind of electrification scenarios, futures for the United States economy. Much of it was released in 2017 or 2018, and it hasn't been updated since then. But the technology that's available has changed. The cost of those technologies has changed. There have been, major policy interventions since then, like the IRA. And so that resource that's now 6 or 7 years out of date, it's not as useful for modeling trajectories from where we are now as it was when it was published. And that, kind of limits its utility. So another thing to be aware of when you're considering a new data set that you might want to work with is what was its journey to you? What happened to it on its way to your computer? So what kind of processing and how much processing has been done? This is important because all processing involves judgment calls and choices. And when you're using data that's been processed, you're relying on somebody else's judgment and choices. And if you trust them and you know what they were doing and why, and you have a similar use case in mind, this can be a huge time saver. One way that we see this very frequently coming up is the combination of disparate data sets that are describing similar things in the real world, but they were not reported identically. They'll often be combined to create a much more expansive data set with either covering a larger area or a longer time series, but there's almost always some level of detail that gets lost in that harmonization process because you end up needing to take kind of least common denominator data. So one example of the kinds of processing that it's helpful to be aware of, EIA reports this table, the fuel receipts and costs table in their Form 923. And it has like incredibly detailed information about like every fuel delivery that was made to a power plant, coal, gas, oil, whatever. Includes the price, the supplier, sulfur content for the coal, transportation method, et cetera. But it comes in dozens of spreadsheets, one per year for the last 20 years. And EIA also has an API that gives you like kind of more bulk programmatic access to data that was collected in the 923 and other forms that EIA collects. And you might think that it would just be more convenient to read data from that API, just pull down exactly what you need and have it cover all of the years. But when you get to looking at the specifics, you notice very quickly that the API aggregates all of those fuel deliveries by state and fuel type and time period. So a ton of that detail that is only available in the individual records associated with a particular delivery, it's only available from the spreadsheets. And then you'll notice that there are some curious gaps in the spreadsheet data where there's no price reported. For instance, in the Northeast, in the winter, natural gas prices they vanish. And that's because utilities are redacting that information as proprietary. But those redacted values do go into the aggregated values that show up in the API. So in this case, like neither of these sources for what is ostensibly the same or conceptually similar data actually contains all of the information that you might want. So more generally, there's a very common trade-off between specificity in data and uniformity of data. Expansive data sets that cover long time periods and large areas very uniformly, they tend to be shallower or less detailed. But if you need that long time series or large area covering lots of jurisdictions, they're going to be much, much easier to work with. Similar information might be reported both at kind of a state regulator level and in the federal agency context. But if you actually need to compare lots of different states or lots of different utilities, kind of apples to apples, it's almost impossible to bring all of that information together from data that you might have scraped out of like Public Utility Commission dockets. And that's a big reason why we've chosen to focus almost entirely, not quite entirely, but almost exclusively on the federal data sets in our work. But if you're working in a state regulatory context, if you're doing legislative support or are actually an intervener in a utility docket, you may have no choice but to use whatever crazy data has actually been submitted in that docket that the regulators are actually going to be looking at. So where you want to land in the spectrum is going to change depending on your use case and the context that you're looking at. So I'm going to talk a little bit about a couple of non-technical data contexts that you should probably be aware of if you care about reproducibility or reusability of data that you're going to redistribute. One is how well is that data being curated by the publisher? So can you actually go back and download the same data tomorrow or next month or next year that you got today? How reliably available is it? And the other is what licensing terms and conditions are associated with the data. If you're really just doing a quick one-off project or a back of the envelope calculation, these things aren't going to be that important, but quick one-off projects have a funny way of sticking around sometimes. So it's good just to know this context when you go into working with a new data set so that you don't get too far down the rabbit hole before you realize that there's going to be a problem with reproducibility or redistributability. So a lot of the data that we work with, basically all of the data that we've worked with is not curated very well. You can't necessarily count on it being there tomorrow or next week or next year. If it's not version controlled and archived really intentionally for long-term access, you can almost guarantee that the outputs will not be reproducible. So if that's important to you, you will need to curate those inputs yourself or find somebody else that's already doing it. So for our project Puddle, we take automatic snapshots of all of our input data sources once a month using a GitHub action. And then those snapshots are archived on Zenodo, which is a research data archiving service that's run by CERN. And then we use Zenodo's API to pull down those snapshots and feed them into our data processing pipeline. So we always know we have the same data going in. On licensing, a lot of people tend to assume that if you can download it from the internet, it's free use, but that's not true necessarily. By default, at least in the US, creative works are covered by copyright and they would be all rights reserved unless you have reason to believe there's some other licensing arrangement. And the way that you can explicitly and intentionally give somebody else in the world permission to do things with something you've produced is a licensing agreement. And there are a bunch of standardized open licenses, many of them produced by the Creative Commons organization, that allow for kind of interoperability between different open data sets. So ideally, you'll find some of these in the public domain, and like all US government works are by default in the public domain. But if it's not from the federal government, you want to dig around and see what kind of licensing is attached to the data that you're going to be using, and just consider whether it's going to be compatible with the use case that you have in mind. And with that, I think we're going to go to our first exercise. And I'll hand it back to Dajon and stop sharing.
All right. Thanks for that. That was a ton of information. So let's take a little bit of time to digest it. I will share a screen and give you an opportunity to do so. Exercise 1. This is what we're going to do. We're going to quickly evaluate basically EIA as a data publisher based on many of the things that Zane was just talking about. The first thing the way we're going to do it is we're going to all use Zoom reactions in response to these questions. They're using a yes reaction or the check mark for the one that's marked with check mark, and we'll use the no reaction, which is the red X, for the one that's marked with the red X. And we're going to, if you are unsure, you can either not react or use the little gray slow down. Yes, as Christina is helpfully demonstrating. The first question, we are actually going to not do that. We're going to use the Zoom chat to just paste a bunch of, to type a bunch of freeform answers, because it is a useful question, but it's not easily framed in a binary way. So that's that. Just to give a little context, obviously Zane explained who the Energy Information Administration is, but they are a federal statistical agency. They collect a bunch of information and then publish it. So first, we're going to spend about 3 minutes poking around at the EIA data, electricity data listings. That's linked right here, to just get the faintest bit of context into what data they publish and how it is published. And then we'll walk through this and flesh out these questions together. Does that sound good to everyone? Are there any questions before we jump into this? Cool. Okay, let's jump in. We'll pop back, or I'll yell at you all in 3 minutes or so. I know it's not a lot of time, but let's bring our attention back. There is this more examples section. We're probably just going to skip it in the interest of time. So don't look at it. And if you have, it's too late, but we'll send this out again after the workshop is over, so you can peruse it at your leisure. So I'm going to fold it up now. Sorry to those who are inside it. Okay. So now that you're all back, yeah. First question is, who is the audience for this data? Just pop your first thought into Zoom chat. Yeah, perfect. I'm seeing policymakers, journalists, researchers, research economists, researching things like the US based researchers, government agency workers. Yeah. So many different types of people, but definitely people who are like trying to use the data to do something else in their job. So like policy workers, researchers, US based. Government agency workers. Yeah, lots of votes for policy, I see. Yeah, I think that's pretty accurate. It is useful data to a broad variety of different people, and it's certainly designed to be used, which is cool. Cool. Now we get to use our Zoom reactions. For the extent of the spatial coverage, like how much of the US is it covering? Would you put a little check mark for it is a narrow amount of the US and an X for it is a wide amount of the US? I don't know why I said it that way instead of the other way. the votes are coming in and everyone is saying wide, and I think that is very reasonable. It's about the whole US. So I'll just type that in. I don't think we need to talk too much about that, though we should acknowledge that it is also only the US. So obviously, um, the rest of the world doesn't factor into this. Um, it's a very US based organization, obviously. Okay. Now, in terms of spatial detail, so like how granular does it get? Um, do you feel like it is very high detail, like, or very like low detail? High being a check mark and low being a red X. Ah, I see we're a little bit more split on this one. Um, why don't we invite someone who thinks it has low spatial detail to make the case, and then someone, oh, they're all everyone is running away from that position. Um, Emily, oh, okay.
I still think it's low spatial. Oh, Jesus.
Mhm. Yeah. T Tell me why. Tell everyone why, I guess.
Sorry, I was having some feedback.
Yeah. This
Um,
sounds great.
I think the highest level of spatial detail you have anywhere in there is like county level, right? For your plants and generators. Other than that, for the most part, EIA data is at a state level, which I consider to be not very detailed.
Emily, do you have something to say
Um,
about that?
I have worked with the EIA data before, and you can actually go in and see individual plant emissions. So I think it is actually pretty high spatially because you can go into exact utilities and it's not just at the county level. Like I've used it to go in and look at individual utilities and their rate offerings for TOUs and stuff like that. So that is my argument for why I think it's pretty high.
Mhm. Yeah, I think if you're looking specifically at the geospatial world, I can see the argument that like county level is not that granular if you're just looking at space shapes. But I also see the point that, and I think, yes, as Zane is saying, latitude and longitude for individual plants and having individual plants is good, is very high granularity, but only county level is just medium, right? Okay, good discussion. But let's move on. Time-wise, do we feel like that is uh, a narrow extent or a wide extent? Seeing a lot of people saying that it covers a lot of time. It does. There are many years of um, data available, and it goes back every year. You know, some data sets go back longer than others, and there's some continuity stuff, but in general, it goes back several decades. So I would agree. But then, how do we think about the time, the level of detail for the time? I'm seeing a bit more of a split again, which I think makes sense. To me, it's sort of medium. Uh, for some use cases, it is a high, and for some use cases, it is fairly low time detail. But does anyone want to speak about why they chose the answer they did?
I mean, just to jump in, I guess it. Can you hear me?
Yes.
Okay. Um, Compared to wholesale electricity markets and those data sets, for instance, which are hourly based, this is very little, much less
Mhm.
granular. But of course, I guess it all depends on your benchmark.
Yeah, I think it's reasonable, right? Like it does have monthly and annual data, which is useful, and in some ways, it is like monthly is fairly granular for some use cases, and it does have some hourly data, but it's certainly not at the same level as what you get from the ISOs or something. Okay, we're almost done with this. Ha. Level of data processing. So green is lots of data processing, red is not very much data processing. has occurred to this data. Right now, the vote is 1-1. I would say, from my perspective, it is relatively minimal. They are collecting data and then they are trying to republish it. There's not a huge amount of imputation or modeling that occurs, but they do try to clean it up in one way or another. So there's some amount of cleaning and they still touch the data, but it's not something like getting pushed through a fancy model or something like that. Again, these also are based on sort of your context. For the update cadence, is this updated regularly or irregularly? How do we feel about that? Or everyone is in agreement? It is published fairly regularly, comes up every year, every month, whatever the cadence is. There are a few data sets that are as needed, but the vast majority of the data you're getting from the EIA is going to be coming out like clockwork. That makes sense. And the last one is the license. How is the licensing? Yes, as Zane mentioned, I think, the US government, when it publishes data, it is by default open. So it is a federal agency, all the data is open. It's great. We're going to get to the breakout groups in a couple minutes. First, we need to talk a little bit about the research question. So for the next 2 exercises, we're going to be looking at some individual data sets and like thinking about them and evaluating them, which is exciting, but it is helpful to have a shared question in mind when you're doing that. And so we have formulated this fairly broad research question, which is, what is the fuel mix for US electricity generation, and what are the costs associated with electricity generation? That includes the fixed and capital costs, as well as the fuel costs, etc. And then for those 2 questions, we want to see how they vary by location, over time, and then not only over time in the past, but in the future. So very broad, which means you need to use a lot of data sets to pick it up, to figure out what's going on. And so we're going to break you out and make you look at several different data sets. For the breakout, there are going to be 4 data sets we have collected. We have gone to the work to find where to download the data, which can often be a challenging piece of the puzzle. But we have links to specific pieces of data for you to look at, analyze, use your eyes and look at, and answer some questions. There will be some from EIA 923, some from FERC Form 1, some from ERCOT, which is like a ISO instead of a federal organization, and then something from NREL, which is a national lab instead of a federal like agency. We'll split you into groups, and yeah, we'll give you 10 minutes instead of 15 because we spent a lot of time talking and having great discussion in the first one. But I'll break it into groups, we'll come back, and then we'll talk about, here, I'll show you the discussion questions as well. What was useful, what challenges you ran into, and how you might work around those challenges. Sort of trying to look at work with specific data sets and then start thinking about generalizing those learnings. So without more rambling, I'm going to kick you out into breakout rooms. Okay, I think everyone is back. Let me take a quick look. Yes, okay. Welcome back. 10 minutes went by very quickly. And I see some people are still typing in notes about what they learned, which is good. We'll spend a few minutes just talking about what is useful about your data set and what challenges you ran into, how you might work around those. And let's start. Let's see if there's anyone who's actively typing who needs more time. Okay, let's start with just group 1, then go through group 2, 3, and 4 and see what people have learned. I think you can just say, in the interest of time, just like one useful thing from your data set and one challenge you ran into. So I'm sure you learned more than one useful thing and ran into more than one challenge. Yeah. Group 1.
we learned that the fuel cost data is available at a monthly frequency, and it's broken down by all the different fuel types. And also sometimes there's multiple observations within a fuel type because they have different fuel costs. And we saw there's also a lot of missing data on the, not on fuel costs, but on the more on some of the other kind of descriptive variables.
Mhm. Yeah, that's a pretty good summary, I think. Did you run into any problems or challenges, like just in the last 10 minutes of looking at this data?
I think the other thing that was talked about was gaps in the data. Someone who may be using this for research and requires more granularity, that may be a challenge. And so finding ways to fill those gaps would be something to think about.
You might need to find another data
Yeah.
set to try to fill those gaps somehow.
Exactly.
Okay. Makes sense. Thanks for going first. That was very kind of you. Group 2, what did you learn from FERC Form 1?
FERC Form 1, very dense, and there's a lot of missing values. Some of them seem to be split up into missing values for different categories of plants, because we're looking at different types of plants. So like steam plants seem to be missing a lot of stuff on purpose, but there's also just generally just a lot of missing information throughout the sheet. And there's two main categories that are kind of summed up. There's maintenance and there's capital costs. So that's kind of nice, but it's still not organized in a super easy to read manner. But it does have some of those totals, which are nice. And then one of the team members said that some of the costs on one of the rows varied wildly for different types of plants, even within the same type of plant, by orders of magnitude. So that could be definitely hard to clean up.
So some data points vary like wildly and may need like cleaning or sort of like figuring out where that variance comes from.
Right.
Cool. I would suppose that counts as a challenge. All right. ERCOT folks, what did you learn? What was useful? What was hard?
It was useful to see the fuel mix for the Texas region, but it didn't have cost data.
All right, so it was a fairly narrowly focused data set. And so again, you have to use multiple data sets to figure out what's going on. Anything else people wanted to add about ERCOT? We'll get to look at all these data sets again in the next breakout room, just through the republishers. So, you'll get one more time with these. Group 4, you talked about NREL ATB, the annual technology baseline. What did you learn about that? What's useful? What was hard?
I would say the hard part is it's a lot of data to comment on within the first like 5 to 10 minutes.
Yeah.
Even if you pick like one, because there's like different sources of energy that they're commenting, the data is available for different classes of technologies that do energy production. So even if you focus on one, even that has like different cost classifications. So just picking like one cell at a time, like we were able to make the comments that we made. It's like, yeah, it does appear that the cost of production will go low, but what it doesn't tell is, have the uncertainties been considered while making these assumptions? Some of them, like especially for capital expenses, the cost of the metals, even that's product, have they considered about the geopolitical issues and all that. Like, how would they affect all that? Yeah.
So you're thinking about like, I'm hearing two things. One is that it is an overwhelming amount of data to sort of digest at once. And then another piece is that like it's unclear what the model inputs were and how they were then processed and like what assumptions they make about any number of things that might happen in the future.
Exactly. And one other point that my teammate, the groupmate pointed out was like, how long have they been doing these projections, and how reliable their projections have been so far?
Right. So like both how much have they varied over time? Like how does the 2015 one compare to the 2024 one? And then also, well, in 2015, they predicted stuff for the last 9 years. We now know the historical actual truth. How correct is it?
Exactly.
Lots of good questions about ATB. And yeah, not enough time to answer them, but definitely time to pose them. Let's me hand the mic to Zane to talk a little bit about these secondary data sources.
So I don't know, one thing you might have noticed in looking at some of those data sets is, if you're thinking about trying to use them programmatically, some of them would be more challenging than others to actually pull into some analysis package. And while there's an understandable desire in a research context a lot of times to try and go back to the original source and start from scratch, if the original source looks like that FERC Form 1 HTML file or a very complex spreadsheet, which is actually a model and not trying to be data, that can be very challenging. And if you need expansive data that covers long time periods or large areas, and it's being reported in different ways at different times or from different places, then a ton of work has to go into harmonizing and integrating the data before it's actually ready for you to use. And if you take responsible for doing all of that work yourself, it can make it hard to reproduce the analysis that you've done, either by yourself in the future or by others that are trying to build upon your work. So if you can find a harmonized data set that's been republished by somebody else that meets your needs, it can save you a ton of time and make it much easier for others to reuse your work. And there's a whole industry that's grown up around taking these not ideal public data sources, cleaning them up, and then charging for commercial access. And there are also some open projects that are trying to do the same thing, and including ours and Grid Status and some others that we'll take a peek at in the next exercise. And there are at least 3 kind of big kinds of work that need to go into doing this, even if the data is clean, which it often is not. And these are combining disparate but conceptually similar sources into a single output. So with the EIA data, this might be taking 20 years of spreadsheets and finding the tab in all of them that is talking about the same kind of stuff and figuring out like which columns in all of those tabs actually refer to the same things and how the names change over time. So you can concatenate them into one big table that covers 20 years of data instead of 20 different spreadsheets. They're all slightly different. So Grid Status, like I mentioned, is an example of a service that does this. They're kind of open. The software behind them is open, although they charge for access to the bulk data that is collected. And what they do is they take information from all the different ISOs, all the different grid operators around the US, and compile it into a single uniform API that lets you kind of work with all of that data in a much more standardized way, rather than needing to understand the details of all of the different APIs. And then there's combining conceptually distinct data sources into a single platform. So this is a lot of the work that Puddle does. We take data from FERC's databases and EIA's spreadsheets and EPA's CSVs and some giant JSON blobs. And if you're accessing all of those original data sources, you need to understand like the weirdnesses and formats that they're all using. And if they're all in one place side by side, you can lower the overhead of access by using kind of a standardized collection of data sets. And having all that data in one place in the same format is great, but that doesn't necessarily mean that you'll be able to use the data sets in tandem with each other. So for example, FERC and EIA both report data about power plants and electric utilities, but they don't use the same names or the same IDs for the utilities or the power plants, which makes it very hard to bring together the different kinds of fuel cost or consumption or cost information or other information that's reported independently in those two sources. And record linkage or entity matching is the process of creating those explicit relationships between related data. We do a mix of manual and statistical methods to try and get these things to work together more easily. And then I think it's useful to think about whether something is initially accessible or whether there's a more kind of comprehensive, deep accessibility. So it's easy to open a spreadsheet, like the ATB spreadsheet. It's not hard to get open, but it is hard to understand what's going on in there. And if you wanted to work with that, those outputs programmatically, just the format of that spreadsheet is very challenging, right? It's lots of little blocks of things that look like data scattered around in different places in different tabs. So if you want to do kind of programmatic analysis, having some kind of bulk access that has like a very, very well-defined structure that is understandable both by a human and a machine will give you kind of a deeper accessibility to that information. So the tools and formats that work well to get kind of a quick picture and intuitive understanding of what's in a data set are not always the same as what you want when you're going to be doing a lot of analytical work that you want to be able to do programmatically and automate to some degree. And that's a conflict that we come into and that all of these data providers are trying to manage at some level with the data they're providing. So now we're going to go back into breakouts and look at some secondary data sources, which may or may not be easier to use than the primary ones.
Basically, you're going to, for every data set, you're going to go to a secondary data source that republishes that data set. So for most of you, that means you're going to be looking at the Catalyst source puddle. For the ERCOT people, you get to go look at grid status, which means you have to go through a couple extra hoops. I'm going to delete this because I think those links are already repeated later. Yeah, you'll get into it. That basically take a look, figure out what's different, sort of write down what you notice, and then maybe think about how you would access that data as well. Looks like everyone is back. Each group, I want to hear one difference you noticed from the original data, and then if any access method appealed to you. So let's talk about NREL ATB. What is one difference you noticed between the source data and the republished data? And did any access method appeal to you?
So let me maybe jump in as my colleague did last time. So I would say that we're discussing the fact that maybe the original NREL is more intuitive to the eye as a first glance because it's organized into this. I mean, it's an Excel file. It has different colors. Things look neater than a dry CSV formatted table. But then once you understand what the data sets are about, kind of the preferences flip in that the PUDL format, it's much more convenient to download, upload it into your R or Stata or whichever statistical software you use and start playing with it. Whereas if you had to do your analysis starting from the Excel file, you would have to, do so much more cleaning until the time is for you to start actually addressing the data that's of your interest.
I think that's a good take, especially since it paints us in a good light. Yeah, so it sounds like the thing that you were interested in was getting the data in SQLite or Parquet format and putting that into your analysis package, R data. That sounds very reasonable and is the intended use case for that thing. So I'm glad that works. Cool. What about the grid status folks? What did you find?
One of the core differences was the access method, whereas it was very clear how to download the ERCOT tables and look at them. It was a little bit less straightforward how to actually access the data and look at it. It seemed more geared towards a programmatic audience, which could be intimidating if you haven't had experience working with APIs before. But it did combine all of the years of data in one, which is great. And it actually had a higher level of granularity than the data that we were originally looking at.
FOMO group 2. What's one difference you noticed between the Puddle version versus the source version?
Puddle version was a lot better defined between the raw files and the data dictionary. With Puddle, it was a lot easier to understand what each of the columns and rows were. So it was really nice.
Did you have any thoughts about how you would personally try to access this data? Like any access method that I appealed? Or did you not get to that?
It was nice that there's like 6 different ways to access it. It just depends on the kind of research and kind of familiarity or with different stuff. Like I've never used Parquet files, so I'm not going to touch those, but there's a bunch of other ways that I would access those.
Okay. And finally, group 1. So the folks who are looking at EIA 923. What was the difference that you noticed? What did you think about access?
There were, again, 6 different ways formats to access the data. There was a web browser and then different like file downloads. So there's like a lot of options for, depending on what you're looking for. And a nice data dictionary. So it's more like easy to know what you're looking at compared to looking at the raw files, although the raw files were there too. And however, it wasn't clear to me how I would know like what cleaning has happened to the data compared to the raw data. I think that would take some more digging than the few minutes we had.
Yeah. As I was talking about in the group, it's a common challenge with republishers to how do you communicate what you actually did to the data in a way that is at the right level, right? You don't want to make everyone dig into the code, but you also want to be precise enough that they know what's going on. So we're definitely thinking about how to do that better. But okay, very quickly, what did we learn? What types of organizations are publishing open data? We got to dig into a few open data sets. We only spent 20 minutes on each in total, but that's 20 minutes more than before. Also, in which situations you might want to use data republishers, or at least like what the difference is between the republished data and the source data. You get to make your own decisions about that. If you want to keep chatting with us for any reason, feel free to sign up for our office hours. There's a link that you can click on, and you sign up for a slot on a Thursday, and we'll send someone to go talk to you. We love talking to people who use our data or want to use our data, so don't be shy. We'll also send out a follow-up email with notes, more detailed notes, and then also supplemental materials as well. So a lot of information about like what other data sources, data sets are out there, how to access them, etc. And then finally, please fill out this very short feedback form. I see 4 cursors have already clicked on it, so thank you. It's always useful to know what we can do better, because we are running another 9 different webinars over the course of the next year. So hopefully they'll just get better and better with all of your feedback. And I think that's it. If you have any last questions, feel free to shout them out or post them in chat. And other than that, please fill out the feedback form and get out of here.